right, so we already talked about adding together fractions and that we need to have common denominators. And that we're pretty good at it with numbers, and there are places where it's going to get more difficult. So part A of the first example is kind of like one step in that direction. It's not too bad because instead of just having numbers, it just has some factors of A and some factors of B, so we can probably figure out what we need as our LCD. What do you guys think will be the proper choice for our least common denominator if we want to add together those two fractions with their current denominators? Stephanie?
15a squared
to the 6th. Okay, do we agree? B to the 3rd. Is B to the 3rd enough to be the common denominator of them? Yes. Okay. So we don't have to combine together all the powers of everything we see. We just need to make sure we have enough that we don't have to cancel any out of any individual denominator. Okay. So for that first fraction that we have, go ahead and go like this. Rewrite it so I can write next to it. So for the first fraction that I have, what do I need to multiply the numerator and denominator by in order to create this common denominator? So 3a, is that good with everybody? So that'll make 15, that'll be a squared, and I already have the b cubed. So I'm going to multiply that same quantity into the numerator. So in the denominator, I have my 15a squared b cubed, like I was expecting to get. And then in the numerator, that leaves me with 6 times a times x. For the second fraction, what do I need to multiply numerator and denominator by? 5b. So that'll make 15. I already have a squared, and then that'll make b cubed. So 15a squared b cubed, and I got matching denominators just like I want. And then don't forget to do that same operation to the numerator. So that'll give me 20 times b times y. Okay. So when I add the fractions together, my denominator stays the same. That was the purpose in creating the common denominator. And in the numerator, I need to add 6ax with 20by. Okay. So all of this arithmetic would be done in the numerator. And then if you can simplify, you do simplify. So the skills that you used yesterday would now come into play. Now you have one fraction. Do these numerator and denominator of this one fraction have any common factors that can cancel out? No? Okay. There's a common factor in the numerator, right? 6 and 20 have a common factor of 2. But is there any common factor of 2 in the denominator to cancel it out? No. So you could leave your answer like this. If you like to factor each portion to check if anything is factorable, it's also completely acceptable to leave your answer like this. Okay. Both of those are the same thing. Okay. If you want to separate the fraction, you can separate the fraction, but there's nothing that's completely common to the numerator and to the denominator. Because the common factor between the first term here in the denominator is a 3, but the common factor between the second term in the denominator is a 5. It's not the same number for each of them. So you could separate this into 2 terms, which is totally okay, but not how you'd probably see them write the answer. I would accept the answer if you did it correctly and had the 2 terms that you needed. Okay? So the same reason that we wouldn't cancel out the fact that this has a common factor of 3 and this has a common factor of 5. If you want to separate it and you want to write 6ax over 15a squared b cubed and just simplify that part of it, then you could cancel out a's. But I can't cancel out an a from the complete numerator as well as the denominator. Okay? And I can't do it piece by piece. I can't keep it looking like this and say, oh, this a cancels one of these and this b cancels one of these. Only if they're separated. If they're still together, you need something that both terms here and the denominator have in common in order to cancel it out of everything that's there. Okay? Anna? Yeah, probably. So that's why I said you probably wouldn't see it written like that. This is considered the more simplified version if we want to actually add them together. Then you're just taking them back apart. Good point. All right, so now we're going to look at part B. So part B is a little more difficult because rather than just having a list of factors in the denominator, like, oh, here's some numbers, here's some a's to some powers and some b's to some powers, we actually have trinomials, and we have to actually look at what those factors are and do work to factor them ourselves. So looking at the first fraction, if I want to factor the denominator there, use whatever skills you have from quadratics to factor. So whether you use like the x or you guess and check, whatever the case may be, to factor that. And then in the second fraction, you can write it as x plus 2 times x plus 2 or x plus 2 squared. So this is what we have. Again, why do I want to look at it this way? Because if I'm trying to come up with a least common denominator, I want to make a list of factors, which means I want to look at those original things in their factored form so I can understand what they're made up of and what I'm going to need to create my new denominator. So what would you guys pick as the least common denominator? So looking at the first fraction, what factors have to be included in the denominator because of the first fraction in this problem? See? Good. We need an x plus 3. And we also need an x plus 2. Okay, because remember, we're not saying, oh, they both have this. That's what I'm looking for in common. A common denominator is going to include everything that's already there and perhaps have to include more if necessary to make them look the same. So then based on the second denominator and what you have listed so far, what else needs to be included in our least common denominator? Keelan? Another x plus 2. Are you guys on board with that? So this one doesn't have an x plus 3. That doesn't mean we take it out of the common denominator. It's there because it's needed for the other fraction. Okay? This second fraction has 2 factors of x plus 2. That means those both should be listed in your common denominator. So far you've listed one factor of x plus 2. Have you listed the other one? No. So if you don't, you're saying you're going to get rid of one of those. There's nothing here that reduces with it. That doesn't make sense. So you need to make sure you're including 2 factors in this case of x plus 2. Okay. So that means in this fraction, once I know what my least common denominator is and what the aim is, that means this first fraction is missing this extra factor of x plus 2 to make the common denominator. So this first fraction needs another factor of x plus 2 if it's going to have the common denominator. The second fraction has both factors of x plus 2, but doesn't have this factor of x plus 3. So that's what I would want to include there. So notice that now both fractions in the denominator will have a factor of x plus 3 and 2 factors of x plus 2. Okay? That means their denominator is common. You could, at this point, if you wanted, write this as one fraction because both of them are going to have that denominator. Okay? Then you have to look at what's happening in the numerator. This numerator consists of x being multiplied with x plus 2. That's being added with the next numerator, which consists of 2 and x plus 3 being multiplied together. Can I go like this? Oh, look, cancel x plus 2 and x plus 2, x plus 3 and x plus 3. Can I do that? No. If the plus sign wasn't here, and all of these factors in the numerator were just multiplying each other, could I start canceling with common factors in the denominator? Yes. But not until everything in the numerator is fully factored, meaning something times something else times something else. No, this times this plus this times this. The plus has to go away. So basically how you have to simplify this numerator is you actually have to distribute, add together like terms, and then check when that's all done, can that be factored where you just have lists of things that are multiplying each other. Okay? So here we'd have x squared plus 2x plus 2x plus 6. x squared plus 2x plus 2x plus 6 is really going to be x squared plus 4x plus 6. Does x squared plus 4x plus 6 cancel? Or factor? Sorry. No. So if it doesn't factor and I can't break it down, is x plus 3 going to be a factor of it? No, it doesn't factor, right? Is x plus 2 going to be a factor of it? No, it doesn't factor. So at this point, that is my answer. The numerator is not factorable, so that's as simple as that's going to get, which means no factors are going to cancel with anything in my denominator, and it's still going to have all of those factors left, and that's going to be my result. Anna?
Will you take it in that form so you don't have to?
Yes. Yeah. You don't have to multiply out the... I'll always take it in a factored form. Or something. This would not be considered simplified because you haven't checked. You haven't distributed things. You haven't seen what could be combined together. In a final answer, this is acceptable. If this did factor, you could list its factors. Okay? You should always check if it's factorable, because if it's factorable and something cancels, you're not done, right? You have more simplifying to do. Any questions on what we've done so far on this slide? No? Are we feeling like this is a little bit review from Algebra 1? We just have to remember how to find the stuff. All right, let's look at part C. I'm not necessarily going to do the try these. I'm going to make sure we get through all the examples, and then you guys will have the try these in your notes packet for extra problems to try, or to try at the end to see if you understand it, okay? We are going to look at part C. So part C is a subtraction problem. So we're going to treat it the same way as we treat addition problems, just being really careful with that subtraction sign and how it affects things. I'm still going to factor my denominator so I can really see what factors they're made up of. So who thinks they could tell me what they believe would be the best least common denominator for this problem? Keelan? 4 times the quantity x minus 3. Okay. So is everybody okay why x minus 3 is included in the least common denominator? So if I look at this fraction, I know from the first fraction, my least common denominator is going to have a factor of x minus 3, and it's going to have a factor of 2. Okay? So if I was looking at that one, I say, okay, these two things have to be in there. Then when I look at the second one, I say, okay, it needs a factor of x minus 3 that's already present. Okay. 4 factors as 2 times 2. It already has one of those 2's listed, but it doesn't make account for the second factor of 2. And that's where I'm getting the 4 from, times the x minus 3. Okay. Which means the second fraction has a denominator that is a least common denominator. So I only need to adjust the first fraction, and that can be adjusted by multiplying by 2. And then both fractions will have the denominator of 4 times x minus 3. And in the numerator, I have 2 times x minus 5 minus x minus 7. Notice how I wrote my minus x minus 7? You're subtracting the entire quantity of x minus 7. That all came after the subtraction sign, so make sure that you're careful with your signs. Okay? So in the numerator here, I end up with 2x minus 10 minus x plus 7. If I simplify that, 2x minus x is x. Negative 10 plus 7 is minus 3. So once I have that common denominator listed in its factored form, and I've done all the work to add or subtract in the numerator, I can then look to see, is this my final answer, or can I simplify it further? So what do you guys think at this point? Zeke?
You can take out the x minus 3 in the numerator.
Good. So there's a common factor of x minus 3 in the numerator and the denominator, meaning that our final answer to this problem is 1/4. Are you okay with this? Hope it's all flooding back to you. Okay. I hope so. All right, like I said, we're going to skip the try these because we'll let you guys have access to those or work on those. And just make sure. All right. We might do this, try this one together. Maybe. I don't know. You guys might just want to do it on your own. Okay, it looks ugly, but it's not that bad. Do I always say that? Okay. So how are we going to do this? Damien?
I have a question. Is
Yeah.
that x plus x over 3 divided by?
Uh-huh. We got some fractions within fractions going on. I see Keelan's hand. Just trying to get some other people to think about it a little bit. How are we going to approach this? Let's try.
I would try to find a common denominator between the two equations, like x plus x over 3. I would try to make it like 3x over 3.
Good. So she's saying she's first just going to focus on the x plus x over 3 and try and combine that into one fraction. So think about it. If somebody had given you something like this, okay, and you wanted to go and do the operations for this problem, I just made it all numerical, right, but it kind of looks like the same format. This means the same thing as 1/3 plus 5 is being divided by 2 plus 1/4. Order of operations says you would do the stuff in parentheses before you would go ahead and do multiplication and division. So your focus would be, what is this? Plus, how do you divide by the reciprocal of this if you don't even know what this is as an individual fraction first? So definitely when you're given these fractions within fractions, you want the numerator to become all one fraction and the denominator to become all one fraction. Okay? So my goal is going to be to rewrite this problem. I want to rewrite it so that the numerator is one fraction and the denominator is one fraction. So I basically want to go do this addition problem off to the side, and I want to go do this subtraction problem. Basically, I'm going to turn this into a problem that you could have done for homework last night or in the math moment today, right? So for this first addition problem, remember, if it doesn't have a denominator, it's over 1. So what's the common denominator between these two fractions in the numerator? 3. So this one needs to be multiplied by 3, and so does this one. Okay. So then I have a denominator of 3. And in the numerator, I'm going to have 3x plus x, which will be 4x. Now, obviously, they can get a little more complicated than this, but the idea would be the same. No matter how complicated this addition problem got in the numerator, if you have to, go off on the side of your paper and treat it like its own addition problem and do all the work. Once you get it as one fraction, bring it back to this problem. Okay? In the denominator, these two fractions would have a common denominator of 6. And 6x minus x would be 5x. Okay? And then we can approach this like you guys did with the problem in the math moment. This is really the same as 4x over 3 being divided by 5x over 6, which means 4x over 3 being multiplied by 6 over 5x. And now we can cancel, since it's just a multiplication problem and everything's kind of already in its factored form because there's nothing being added or subtracted together. We can cancel common factors. So like x will cancel, 3 goes into 6 2 times. So I would get a final answer of 8/5. Okay? All right, so why don't you guys try for the last couple minutes to try this, and then I'll put the work up for it also. Okay, go. Try it on your paper. I don't want to is not an acceptable answer. So work through and check. Okay, I did the work kind of quickly. The stuff you see in red right here is the work I did to add together the stuff that was in the numerator. Okay, my common denominator had to have an x plus 2 and an x minus 5, so I put the factors in the fractions that weren't already there. Okay, that gave me the common denominator, and then in the numerator gave me 2x minus 3. Okay. So that replaced what was in the numerator. That was being divided by this fraction that was in the denominator right here. Then I knew I had to use the reciprocal of that to do the multiplication problem. And before I did the reciprocal, I factored it so that when I did the reciprocal, I could write it in factored form and cancel stuff out. So when I flipped this fraction, the factors went to the appropriate spots. Okay? And then I canceled out common factors to get what was left. Okay? So it didn't matter how crazy the addition or subtraction problem was in the numerator in this case. I do it like I would do a separate problem and then come back to my original problem and finish the division stuff. So basically, all this stuff is kind of getting meshed together, right? You can't not know the stuff from yesterday and just get through the addition and subtraction stuff, because at the end, some things will need to be simplified. Some things contain both ideas in one problem, and you'll have to be able to get through them. Okay? So your homework tonight is going to concentrate on these types of problems. Anything in this homework that says to list restrictions, don't worry about it here. Okay? Like I said, it's going to be more for us when we're solving, which will be our focus when we work on something over the weekend, and then when we're graphing when we come back from doing that. Okay? So more of next week's type of stuff. Here, I want you to be able to get through the addition and the subtraction, okay, and any simplifying stuff. So tomorrow you'll have your quiz on the log stuff when you come in. After your quiz, you'll turn in homeworks 1 through 3, which were the review things that were finished earlier this week, and we'll stamp homeworks 1 and 2 from this unit that you should have completed. Is everybody good and on track and you understand what you're responsible for? Okay.